Hello all. Today we'll discuss about the tag position identification in an indoor localization by using a three circle intersection method. In previous video, we identified the tag location by using a triangle method, where the three tag when where the tag location is identified between the 0 to 180 degrees because the triangle can support a 0 to 180 degrees only. And if you are moving more than the 180 degree, we can get a false tag location or a mirror image tag location that is acceptable for some applications. But if we are using the identifying if we require to identify the tag location at 360 degrees, then it's better to go with a three circle intersection method, where and the more the anchors we deploy, the more accuracy we can get. But for a 360 degrees tag location identification, three anchors is sufficient. So if you are seeing in this image, we are placed the anchor 1, A1 at minus 50 comma 0. I'm assuming that point as minus 50 comma 0. And from 100 centimeters away, I'm placing the anchor A2. I'm assuming that as a 50 comma 0. And I'm placing a third anchor A3 at 100 centimeters away from these three center point of these two anchors, anchor A1 and A2. So I'm assuming this point as 0 comma minus 300. Now these three are my anchors positions, and they are static, and I know their coordinates. And when a tag is placed near to this anchor, it start communicating with each anchor and sends its distance respectively. So tag 1 is sending its location to the anchor distance to the anchor A1 at 91 centimeters away. So a 91 circle is drawn, 10 centimeter circle is drawn, and this same tag is away from the anchor A2 from 140 centimeters. So 140 centimeter radius circle is drawn, and same tag is away from the 33 centimeters that anchor 3, a 33 centimeters circle is drawn. Now the intersection of these 3 points gives the exact tag location, but in a practical case, intersection of the 3 points may not be possible because there are some offset in the distance measurement. So we can calculate the intersection of the two circles at least, and we can take a third circle as a reference to get the more accurate tag location. So let's go into the code. So this code is very much self-explanatory as previously I explained. So I just importing these some libraries like serial port because these anchors are communicating via serial port. A time to get a proper synchronization, math library, and a simple library for the arithmetic operations to solve the equation, turtle library for drawing this graphical plot. So I'm creating a three objects, serial 1, serial 2, serial 3 for each circle A1, A2, and A3. These are the basic functions used to draw the graphics on the turtle. I'll not go through it. I'll just jump into the logic in the main loop. So the main loop, it starts with some installation for the graphic installations. In the loop, in the while loop, I'm trying to read the serial one data and converting because the data comes in text. I'm converting into the string, and just added some exception, but in case I didn't get a proper data, I'm just initializing with a default value. So int a, int b, and int c are the radius of the each cycle by default, and it's getting its value from the each serial port, serial 1 and 2 and 3. So these three serial ports I'm reading, I'm just added some exception in case if something wrong happen, my program should not crash. I'm flashing these three serial ports just to get a limit in the random or noise data. So I'm just printing A, B, and C values. That is nothing but the circle A. Int A is circle A1, so int B is circle A2, and int C is circle A3 radius. So I'm just printing just for the debugging purpose. Once the radius is come, I just then I form the three equations, equation 1, 2, 3 for the each circle, and then I'm trying to solve this equation by using the simple library. So when three equations solved perfectly, that is the ideal case. I'll get a one tag point, one x and y comma point, which is the ideal case, but practically it's not possible. So if three circles are solved properly, then I'll get some value in my solution. If the length of the solution is greater than 1, then the three circles are intersect perfectly at same point. And at this point, and I have a x and y coordinates, I'm just drawing the tag location, and a circle is a small dot, and then with that I'm just doing some other operations. You can from this point, I'm just printing the solution here. So this is the print of solution. And once you get the x and y coordinates, you can do any operations because you know the boundaries of your anchor, and later it's up to you how can you tailor this code. But what if these three circles doesn't intersect each other? That is most likely to be case. Then three circle intersection not possible. Then I'm trying to compute the each and every circle, each a pair of circles, like computing circle 1 and 2 for the intersection. Then I'm trying to solve the equation 1 and 2. If the equation 1 and 2 again comes to two possibilities, that it can have the solution can have a complex number or solution may not have a real number. If solution having a complex number doesn't have a complex number, then if solution doesn't have a complex number, then I'm trying to solve then I'll get a two intersection points, x1 and y1 and x2 and y2. Then I'm using a third circle as a reference point to get the accurate tag location. For example, here you can see circle A1 and A2 are intersecting each other, but circle A3 is not intersecting with these two circles. Yeah, however, intersection with a second circle, but this intersection of the two circles sufficient, and I'm taking a third circle as a reference point to identifying the tag location. Okay, so similarly, I'm going to the if condition, one for the does have a complex number, one doesn't have a complex number. And for example, let's take circle 1 and 2 are the too small for an intersection. Then I'm printing its intersection point is not possible. Then I'm trying to intersect with a circle 1 and 3. Then same logic repeats. Let's say if circle 1 and 3 intersection also not possible, like 1 and 3 also very small. Then I'm trying doesn't intersect with each other. Then I'm trying to identify intersection with the circle 2 and 3. Then the same logic follows. If the three circles radius are very much small, then they doesn't intersect with each other. Then I just print that yeah, no circle intersection is found. So in this way, each circle pair I have selected to identifying the intersection point, and third circle I'm using as a reference to identify the nearest tag location. So let's go to the demo. So today we'll know that the tag location by using a three circle intersection points. Let's run the code. So the graph will be drawn to identify the three circle intersection points. The three anchors are there A1, A2, and A3. I'm drawing some boundaries to make decision. A1 is a green color point, and A2 is red color, and A3 is a blue color point. So when I'm placing the tag near to the A1, then a green circle will be drawn with a smaller, and a red circle will be drawn A2 because it's far from the A2, and the blue color will be drawn even bigger because it's much far from the A3. So the intersection of these three circles gives the exact tag location. But in a practical case, the intersection of three circles may not be possible because each circle have its own radius. So what I'm doing, I'm considering the at least two circle intersections. So that will give the 2 points, and I'm using a third circle as a reference to identify the exact tag locations. As you can see that I'm moving the tag position near to the A2. The A3, A2 circle is shrinking and A1 circle is increasing. So in this way, each circle will be drawn depends upon the radius or the distance from the tag. An intersection of these circles will be gives the tag location. With this help of these circle intersection points, we can identify the tag location in 360 degrees. In the previous triangulation method, we can only identify the tag location from 0 to 80 degrees, but this method will give 360 degrees tag location identification. So as I'm moving the tag near to A3, the A3 blue color circle is shrinking out, A1 circle and A2 circles are growing bigger. An intersection of these three or at least two circles, and with respect to the reference of the third circle, will give the tag exact location. So I'm printing the tag coordinates, and now we can see the tag cross 270 degrees, and it's reached to the third quadrant, crossing the quadrant 2, 1, and 3 and 4, 4 and 2. Thank you.